Okay, so good evening, everyone, and this is lecture number 1, and we are dealing with problems in JEE Advanced. We'll start with thermodynamics, and let me get straight away into a problem to see how good you can solve this one. So this is a problem based on KTG, and let's see if you can do this. Okay, give me a moment. I'll just shift it. Oops, this got shifted. Okay, now I can go ahead with this problem. New share. Screen share. Okay, let's see if you can do this one. So this is a problem which is based on kinetic theory of gases. As you can see, a cubical block of side 1 meter. It contains helium gas. Atomic mass or atomic weight is 4 at a pressure of 100 Newton per meter square. During an observation time of 1 second, an atom traveling with the RMS speed parallel to one of the edges of the cube was found to make 500 hits with a particular wall without any collision with other atoms. R is given as 25 by 3. K is given as 1.38 into 10 raised to the power minus 3 minus 23 joules per Kelvin. We have to find the temperature of the gas. Can you do this? Then the average kinetic energy per atom and the total mass of helium gas in the box. Have you done a question before like this? This question has some part of KTG, it has some part of gas loss, and simple question. Can you do this?
I will try, sir.
Okay, I'll give you a minute. I'll give you 2 minutes to go through this. Okay. Let me do it.
Yes, sir.
How it is to be done? It's a simple question, right? Just see how this is done. So you know the volume of the box is 1 meter cube. Just give me a second. You know the volume of the box is 1 meter cube. Yes or no?
Yes,
Then
sir.
the pressure of the gas is also given to you. Yes or no?
Yes, sir.
Then we have to find the temperature of the gas. How are you going to do this? It's pretty simple. Did you see the solution? Do you see the solution? Let me just change it to a different format because I won't be able to write in this format. So let me just change it to a different format where I can write it. Right, this one will be better. So volume of the box. Okay, let me just go back. Where is this? Charles law, Charles law, speed, acceleration. Which one did I open? This. Okay, acceleration. Okay, here. Here is this. Degrees of freedom. Which thing I will? Okay, this one. Now I'll be able to write. Okay, so you see, the volume of the box is 1 meter cube, and the pressure is 100 Newton per meter square. Let us say the temperature of the gas is T. Now, how you got to solve this is by applying a fundamental principle. You can see this is a cubical block whose length, let us say, is 1 meter. Let us take it as L. Now, it's given that time between two successive collision is 1 by 500. Yes or no?
Yes, sir.
Right. This time between two successive collisions. So a particle starts from here, goes till here, and then it will come back. So between two successive collision, the time interval will be 2 times L by VRMS. Yes or no?
Yes, sir.
L is the length of the cube. Now this 2 L divided by VRMS will be equal to 500. From here you can find out the RMS velocity. Yes or no?
Yes, sir.
Then this RMS velocity will be equal to root over 3 RT by M. Yes or no?
Yes, sir.
And that is how you get the temperature. What were you trying? Tell me, what were you trying? Trying the same thing or had a different idea?
No, sir. Same thing.
You're trying the same thing or you were doing something different?
Uh,
Tell me
I didn't take in the two,
how
sir.
you were trying it.
I didn't take in two.
Different? Something different? Did you use 1 by 500?
I didn't take in two, sir.
You didn't take 2. Okay.
Yes.
Okay. Not a problem. Then the rest of the question I think is pretty straightforward. Average kinetic energy per atom
Yes, sir.
or per molecule 3 by 2 kT. We know this, yes or no?
Yes, sir. Yes.
We can calculate this. We know the pressure, we know the volume, we know the number of moles. No, we don't know the number of moles because we don't know the value of mass of the gas. We know the value of R, we know the value of T, we know the molecular mass. You can calculate the mass of the gas present here. Yes or no?
Yes, sir.
So that is how you calculate the mass of the gas present here. I hope you understand this.
Yes, sir.
Okay. You have an idea about transitional kinetic energy per mole and transitional kinetic energy per molecule? Yes or no?
Yes, sir.
Okay. Then can you solve this small question? Such type of questions will come probably in your single option type question. Can you solve this one? Two ideal gas, temperature T1 and T2 are mixed. There is no loss of energy. If the masses of the molecules of the two gas are M1 and M2 and the number of their molecules are N1 and N2 respectively, find the temperature of the mixture. Can you do this? Here it is not given whether they are monatomic gases or diatomic gases. Nothing has been said. So what we'll assume is that they have the same atomicity. So if they are monatomic, they are both monatomic. If one is diatomic, the other one is also diatomic. Do you understand this?
Yes, sir.
Okay. Can you tell me what is the temperature of the mixture? And you remember this whenever you do, whenever any question of this type comes, remember this concept. I'll give you a minute to try it. That is correct. That is correct. There is no work done. There is no heat energy given or lost. So basically, you equate the total internal energy. Do we understand this? Yes or no?
Yes, sir.
Okay, so this is good. And again, a small one, but a conceptual one. Can you solve this? Now, this involves a bit of so-called atomic structure or modern physics combined with thermo, and these are the types of questions that you can expect in a JEE. This one. Can you solve this? I'll give you time. 2 minutes. The question is pretty simple. The first excited state of hydrogen atom is 10.2 electron volt above its ground state. Above its ground state, what temperature is needed to excite hydrogen atom to the first excited level? At first excited level is 10.2 electron volt. You must be knowing this. You should be knowing this. Well, since modern physics is not covered, that is why the value is given. How much, what temperature is needed so that the atoms get excited. I'll give you time.
Not striking, sir.
The approach is very simple. You need 10.2 electron volts of energy, and you must know what is the energy, average kinetic energy of one atom of hydrogen. If you know this, you equate the two and you get the answer. Shall I show you the calculations?
Yes, sir.
Okay. One thing is there, you have to convert electron volts into joules. I hope you know how to do it, right? So it's pretty simple after that. See, per atom, the average transitional kinetic energy, never forget this term, 3 by 2 kT will come in various form. 3 by 2 kT is the energy that a hydrogen atom has at temperature T. That must be equal to 10.2 electron volt. To convert electron volt into joules and you get the value of your temperature. You got this? Simple
Yes,
question.
sir. Okay, sir. I understood.
Simple question that could come as a single option correct, and you should be able to do it. Okay, shall we move on to the
Yes,
next
sir.
thing?
Yes, sir.
Okay, so let us move on to, I think, thermodynamics. And you know what is a thermodynamic system, what is a surrounding, what's an isolated system? You know this, right?
Yes, sir.
You know what is a thermodynamic state? Is defined by the parameters pressure, volume,
Volume.
number of moles, and temperature. You know this?
Yes, sir.
You must know the value. You must know what do you mean by thermal equilibrium. By thermal equilibrium, we mean that the body, if two bodies are in thermal equilibrium, we mean that the bodies are at the same temperature. Yes or no?
Yes, sir.
Okay. Then you must know the internal energy of a gas, and internal energy of a gas consist of kinetic energy and potential energy. For ideal gases, we take the potential energy as zero. You know this? Yes or no?
Yes, sir.
So for an ideal gas, we only take the total energy as the kinetic energy, and that is always equal to NCV delta T. The change in kinetic energy is always equal to NCV delta T, where N stands for the number of moles and CV stands for molar heat capacity at constant volume. Do you know this? Yes or no?
Yes, sir.
And this is a state variable. That means the change in internal energy does not depend on path. For any path, whether it's for any process, the change in internal energy will always remain same. It only depends on the initial and the final value. Correct?
Yes, sir.
Then we come to the part that you were talking, thermodynamic process. Any process which changes the state of the gas. Remember PV and RT. We are not going to change the number of moles in a gas. We are not going to take the gas out or put the gas in. what we are going to do is that we are going to change either the pressure or the volume or the temperature. But remember, we cannot change only one, because both for all of these four quantities are related to each other. So if you change pressure, volume or temperature, something else will change. So either you will change pressure or volume, or you will change pressure or temperature, or you will change volume or temperature, or you will change all the three, P, V, and T. Yes or no?
Yes, sir.
Okay, depending on that, we have different processes. We'll go through these processes, but before going into that process, we must understand that we will be using the first law of thermodynamics here, and the first law of thermodynamics looks like this. Yes or no?
Yes, sir.
Delta Q, whatever amount of heat energy we give, is equal to delta U, change in internal energy plus the work done by the gas. When it is positive, when it is negative, I hope you know this. Yes or no?
Yes, sir.
Okay, so there is no point of discussing it. This is known. Now, what we are going to do is we are going to go through different processes, and we are going to draw the PV diagram, VT diagram, and PT diagram. This PV diagram is sometimes known as the indicator diagram as well. We will be going through cyclic process. Do you know what is a cyclic process?
Yes, sir.
In a cyclic process,
Work done
we
is
start at the same point and we reach at, and we, after a series of process, we go back to the same point. For a cyclic process, the change in internal energy is always zero. Do we know this?
yes, sir.
Yes or no?
Sir.
For a cyclic process, the change in internal energy is zero, because you start from the first point and you come back to the same point. Therefore, the change in kinetic energy is zero. Yes or no?
Yes, sir.
Non-cyclic process, then we have quasi-static or equilibrium process. The quasi-static process is a very small, very slow process where at all points of body the system is supposed to be in equilibrium. Then we have reversible and irreversible processes. There's no point of discussing this. Then you must know how do you find the work done by a system. It is integral of pdv. Yes or no?
Yes, sir.
Okay, now we can discuss work done in some special cases for all these processes. If the volume is constant, the work done can be given by the area under PV graph. Yes
sir.
or no?
Yes, sir.
So this is the PV graph. If you find the area under PV graph, you will get the work done. If the volume is constant, this is known as a constant volume process or isochoric process. The work done is zero. Yes or no?
Yes, sir.
Okay. Then if you have a constant pressure process, an isobaric process, the area is a simple rectangle P into delta V. Yes or no?
Yes, sir.
If it is expanding, we will take it as positive. If it is contracting, we will take it as negative. In a cyclic process, we talk about the cyclic process, the change in internal energy is zero. So the work done is the area in between the graph, and that work done is this area, and this is also the heat given, the net heat lost or net heat gained in this process. Do you know this? Yes or no?
Yes, sir.
We know this. If the cycle is going clockwise, work done will be taken as positive, and the cycle is going anti-clockwise, the work done is taken as negative. Do we know this?
Yes, sir.
Okay, there is no point of discussing this. Then we come to first law of thermodynamics. First law of thermodynamics we have already discussed, so there is no point of going to it. Without going to that first law, let us solve a simple question that would tell us how to solve any other question. So this is an example. The pressure in a monatomic gas, we have a monatomic gas, increases linearly. Understand the meaning of linearly? At a constant rate from 4 into 10 raised to power 5 Newton meter square to 8. This multiplied sign I think is missing. When its volume increases from 2 meter cube, 0.2 meter cube to 0.5 meter cube, calculate the work done, increase in internal energy, amount of heat supplied, molar heat capacity of the gas for this process. Remember, molar heat capacity for different processes would be different. We'll be discussing those processes in detail. Let us first do this question. I'll give you time to do this. Okay. So, this is the PV diagram. Pressure increases linearly, so it is a straight line. Initially is 4 into 10 to the power 5, then it is 8 into 10 to the power 5. Volume is given as this. We just need to calculate this area. Yes or no? Area of a trapezium,
Yes.
right?
Yes, sir.
Did you calculate it correctly? Or is this wrong? Some calculation mistake on your side or on the side of the book? You do it. You did it in the correct way, beta. Same way
Yes, sir.
or differently?
Sir. Mistake मेरा sir.
Yes, bacha.
The calculation mistake हुआ. Calculation mistake हुआ sir.
Calculation mistake. nahi. You should not be doing calculation mistake, beta. Anyways, chalo. Can you do the next part without doing any calculation mistake? Next 3 parts.
Okay, sir.
Internal energy, change in internal energy, the heat given or lost in this process, and can you find the molar heat capacity in this process without making any mistake? I'll wait for you. Give you time. Do you need time or you have calculated it? Have you calculated the change in internal energy? Shall I help you out? Remember, change in internal energy does not depend on the process. Yes or no?
Sir.
Yes. So in any case, the change in internal energy would be given by NCV into T2 minus T1. Yes or no, beta?
Yes, sir.
Now, it's a monatomic gas, so you know the value of CV. Yes or no?
Yes, sir.
So basically, you have to do N into T2 minus T1. And N into T2 minus T1 is nothing but equal to CV into P2V2 minus P1V1. Yes or no?
Yes, sir.
That is how you get your answers. Am I clear?
Yes, sir.
Then how do you find the heat given a loss? It's very simple. You just add both of these. Yes or no?
Yes, sir.
How do you get the molar heat capacity? Heat divided by N
Delta T.
delta T. And that is how you will end up with your answers. Do we understand this?
Yes, sir.
So that was a question based on your graph. If that was question was not given in terms of language, it could have been given in terms of graph. Anyways, that is how that question has to be solved. Do we understand this, bacha?
Yes, sir.
Will you be able to solve the next one now?
Yes.
Remember, we have just not seen the different processes, but we are just solving questions straight away. We'll be dealing with all the processes one by one. Don't worry. Let us solve some general question first.
Okay, sir.
Are you ready for the next one?
Yes, sir.
Here it comes. When a system is taken from state A to state B in figure on the path A to C to B, so that part is the upper path. 60 joules of heat flows into the system, heat flowing into the system, and 30 joules of work is done. How much heat flows into the system in the part A to D to B, which is the lower one? If the work done is 10 joules. When the system is returned from B to A along this path, the work done is minus 20 joules. Does the system absorb or liberate heat? How much? And then you are asked, if energy at point A is 0, energy at point D is something, what is the heat absorbed in the process A to D and D to B? Will you be able to solve this? Confident? Just remember simple things
Yes, sir.
and I'll give you time. Will you be able to solve this, beta?
Yes, sir. I will try.
Okay, I'll give you time. Yeah, so answer for the first one is 40 joules. Okay, so first of all, you calculate on the first path, part A to C to B, you can calculate that change in internal energy will be, which will be UB minus UA, that will be 30 joules. Yes or no?
Yes, sir.
Now this change in internal energy does not depend on path. So you go along any path from A to D to B, this change in internal energy will be same. Work done is given, so you can get
Yes, yes, sir.
the amount of heat in this process from A to D to B. Part number 2 done. Part number 3, along the curved path, now you are trying to come back. Now amount of heat is, final position is A, initial position is B. So UA minus UB, and work done is also given. So you get minus 50 joules. That means heat flows out of the system. Once you know from A to D how much is heat given or heat lost, you know the energies at point A and point D, you should be able to calculate the third part. Yes or no?
Yes, sir.
Were you able to do it with all the correct concept and got the correct answer?
Yes, sir.
Okay. Now, you can expect a question on this first law in the melting and the boiling process. Have you done any question on the melting and boiling process in this? So I'll just show you a quick um, theory behind this. In melting process, whatever you do, I mean, if you are melting ice, heat will be absorbed in the melting process. Amount of heat absorbed will be m into L. Do we understand this?
Yes, sir.
Then this delta Q must be equal to delta U plus delta W. Here, so we imagine that there is no work done in this process. So delta Q and delta U will be equal, assuming that there is no work done in the system. Will you remember this? This is the theory behind it. If there is a change in volume at constant pressure, which normally happens when you are melting ice and all that, then this term will also come. We will see a question if it is there in this. Similarly, you can use the same thing for a boiling process.
Yes, sir.
In the boiling process, same thing will happen. You, instead of m into L for melting, you will use m into LV for the boiling process. Do we understand this? And here the change in volume will be too much. From solid to liquid, there might not be such uh, large change in volume, so you may neglect that work done. But when you are changing from liquid to gas, there will be a substantial change in volume, so the equation will look like this. Do we understand this?
Yes, sir.
So can you solve a question if this comes on this point?
Yes, sir. Right.
And these are the questions that if you have not done beforehand, they might be troubling you in the exam. So here is the question coming on this example. 1 kg of water at 373 Kelvin is converted into steam at the same temperature, 100 degrees Celsius, that is. Volume of 1 centimeter cube of water becomes 1671 centimeter cube on boiling. What is the change in internal energy of the system if the latent heat of vaporization is 5.4 into 10 raised to the power 5 calorie per kg? So things are given in terms of calories. You have to convert everything in one unit, whether it is SI or CG. S doesn't matter. I'll give you time to solve this. I hope you can do this. Can you do this? I've already given you the theory behind it. I hope you can do this. A minute. Okay. I hope you could do this. The question was pretty simple. It just required a bit of calculation. You first calculate the volume of 1 kg of water, then volume of 1 kg of steam. Then you calculate the change in volume. You can do it in centimeter cube, or you can do it in meter cube. Pressure, it is 1 atmosphere. So you just find out the work done. Yes or no? You did the same thing.
Yes, sir. I
You
did.
get this as in joules, so you convert it into calories. I mean, there's just the problem of that conversion, nothing else. Then you can apply delta Q is equal to Q minus W. Q is M into L, mass is 1 kg. Yes or no?
Yes, sir.
Then you just subtract, add, and you get
Part.
the change in internal energy. And as you can see, the change in internal energy is quite high, and that is why 1 kg of water at 100 degrees Celsius and 1 kg of steam at 100 degrees Celsius, steam will cause a lot of burn because it has a lot of internal energy, extra internal energy. Do you understand this?
Yes,
That
sir.
is the reason that the volume changes a lot, and you have a lot of heat of latent heat of vaporization, and that is why you get burn with steam and not so much with the same water at the same temperature. Do we understand this?
Yes, sir.
Shall we move ahead?
Um,
Any problem? Any doubt, beta?
yes, sir. Just wait, sir. Observe.
Okay. Now let us go on and see the different processes
Sir.
in detail. And
Yes.
remember these simple
Previous
things.
page. 1 second.
You have
Previous.
not noted it down, beta?
Sir. Previous
Okay.
page.
Here is the entire question with the solution. So basically, do you understand the concept? You find out the change in volume multiplied by pressure. That is the work done. Delta Q is delta U plus delta W. Delta Q is M into L. So delta U is ML minus the work done. The only thing is something we are given in SI unit, something we are given in CGS unit. You just have to convert it from joule to calorie or from calorie to joule. That is the entire thing. You might not get such a problem. I mean, in terms of the calculation part, you will not get in terms of calculation part, you will not get such a difficult question. Calculation would be pretty simple if this question comes. Okay,
Yes, sir. Okay.
got this?
Yes, sir. Got.
Okay, note it down.
Yes, sir.
Not a problem. Note it down. Then we
Yes,
move
sir.
on
Yes.
to note it.
Hmm.
Then we can move on to all these processes one by one. Isochoric, sometimes it is also known as isometric pressure. Here the volume, as you can see, is remaining constant. The slope of pressure volume curve is infinite or not defined. The slope of volume pressure curve, sometimes they might give you the reverse of it. Instead of PV graph, they might give you VP graph. So must remember this. Equation, pressure is constant. Hmm? Pressure is constant? No. Volume is constant. Is written wrongly. Volume is constant. Pressure and temperature are variable. So you can write P is directly proportional to T. Yes or no?
Yes, sir.
That's it. Work done in this process. As you can see, there is no area, no change in volume. Work done is 0. Delta Q will be equal to delta U.
You.
That means the entire heat that you give to body or the system in this process, this entire heat is utilized to change the internal energy of the system. Will you remember this?
Yes, sir.
And therefore, in this process, the specific heat is known as specific heat at constant volume. Delta Q will be equal to NCV delta T. Here delta U and delta Q both are same, and therefore this specific heat is known as molar specific heat at constant volume. We understand this, yes or no?
Yes, sir.
Here is a simple question based on this. Remember, the question might be a bit complicated in terms of the calculation. Please do not waste your time in calculations. If you understand the question, just let me know. If you understand the concept behind this, because when the question is made and they give some realistic value, so the question might look a bit difficult in terms of calculations. Remember, these type of calculation they do not come these days. Okay. So here is the question: an ideal gas has a specific heat at constant pressure. Cp is given. I hope you know how do you get Cv from Cp. Yes or no?
Yes, sir.
Okay. So the gas is kept in a closed vessel of volume something.
Okay.
You can just take the volume as something at a temperature of 300 Kelvin, and a pressure is given. An amount of some delta Q is given to the gas. Calculate the final temperature and pressure of the gas.
Yes.
So just not look at the values that is given. That is not important. Important is the concept of how you do it, because such values, the values will come at some point, but it will not be such complicated. They will be giving values in such a way that they are getting cancelled and the calculations are simple. So I'll give you a minute to solve this question and tell me how you have done this. Okay.
First, we have to find PV is equals to NRT from. We have to find
PV is
number of
equal to nRT, but you don't know. Okay, you know the initial temperature. You want to calculate the number of moles. Okay, done. Then
delta Q equal to NCP delta T. We have where there we will get T2 final temperature.
no, that is K. Okay. Where will you use this amount of heat that is given to the system? Where will you use that? Have you used this 2.49 into 10 to the power 4 joules of heat energy? Have you used it in the calculations anywhere? Yes or no?
No, sir.
If you have not used this, that means you have not utilized the entire data given in the question. So you might not be doing the correct thing. Shall I do it? Shall I show you how to do it?
Yes, sir.
Okay. So it is to be done. First of all, you have to tell me what type of process is happening here. It is a process which takes place in a closed container. There is no moving piston. So the volume of the gas remains constant. Yes or no? The gas is not going out. The gas is not coming in. The volume of the gas is remaining constant. Yes or no?
Yes, sir.
It's a process that takes place at constant volume. First of all, you calculate the value of Cp. From Cp, you calculate the value of Cv. Then you know that this is a process that is taking place at constant volume. So work done in this process is zero. Did you realize it? Work done in this process is zero.
Yes.
So whatever amount of heat you are giving, that is changing the internal energy of the gas. Yes or no?
Yes, sir.
Now this heat given is equal to delta U, and delta U is always equal to what?
Q. Delta Q.
Delta U is always equal to
Heat given by the system.
delta U is always equal to NCV delta T. As you are correct, you have to calculate the number of moles. Then from delta U, you know the value of Cv. You can calculate the change in temperature. Once you get the change in temperature, you will get the final temperature, and then it's a process that takes place at constant volume. V is constant, so P by T would be a constant. P1 T1 would be equal to P2 T2, and that is how you will get the value of P2 from P1 T1 and T2. Do you understand this better?
Yes, sir.
Do you understand what you were doing correct and where you were a bit confused? Do you understand this?
Sir.
You were correct here in this step to find the number of moles. Yes, you'll have to calculate the number of moles. But then from number of moles, how do you calculate the change in temperature or the final temperature? You do it understanding that this is a process taking place at constant volume. Okay. Remember, the name of this chapter is thermodynamics, and we are doing thermodynamic process. Will you be able to do the next question? Yes or no?
Yes, sir.
I think you will be able to do it fast. So look at the question and tell me how it has to be done. The question is coming to you right away. How will you do this one? This is a straightforward one. Just tell me. How will you do it? 5 moles of oxygen. Remember, oxygen is a diatomic gas. Is heated at constant volume from 10 degree to 20 degree. What will be the change in internal energy? So you simply put the formula. Yes or no?
Yes, sir. NCP delta T.
NCV delta T, and that is how you do it. Remember, the previous question was also as simple as this one. The only thing is number of moles was not given, and it was not said that the process is taking place at constant volume. Do you understand this? The difference between the previous one and this one? Same question. Yes or no?
Sir.
But in that question, number of moles was not given directly. Pressure and volume and temperatures were given, and it was not said that the process is taking place at constant volume. So be very peculiar about the language of the question. Shall we move ahead? Shall we move ahead, beta?
Yes, 18. Yes, sir. Minus 18.
Shall we move ahead now?
Yes, sir.
We come to the next process, which is isobaric. Isobaric stands for constant pressure. Pressure is constant, yet as written, volume is constant. Pressure is constant, so volume is directly proportional to T. Change in pressure is 0. Work done
PdV.
is P into delta V. P is constant, P comes out, so simply it becomes P into V2 minus V1 or Vf minus Vi. From first law of thermodynamics, you can write delta Q is delta U plus P into V2 minus V1. And from here, you can derive the equation that Cp is Cv plus R. Do you know this? Yes or no?
Yes, sir.
Okay. Here you must understand that in isochoric process, the entire heat was utilized to change the internal energy of the gas. Here it is not going to happen. Some amount of heat will be utilized to change the internal energy, and the other amount, the rest amount of heat will be doing some work. Yes or no?
Yes, sir.
To calculate the work done, you can simply calculate this area. It is pretty damn simple. The PV graph, the slope for this particular process is 0. Do we understand this? Yes or no?
Yes, sir.
This is known as isobaric process, and the molar heat capacity in this process is known as Cp. We know this? Yes or no?
Yes, sir.
Okay. Let us move ahead and deal with a problem. And the problem here is this. We have already discussed this, and I hope that you can do this for me. These are the type of problem that will come in the JEE, not main. It's beyond the capacity of main. JEE advanced, and you might get caught. Here's the problem. It's on a melting process. We have already discussed the melting process. So here comes the problem. Shoot at normal pressure and 0 degrees Celsius temperature, volume of 1 kg of ice is reduced by 91 centimeter cube on melting. Latent heat of melting of ice is 3.4 into 10 raised to the power 5, 10 raised to the power 5, multiplication missing. Calculate the change in internal energy when 2 kg of ice melts at normal pressure and 0 degrees Celsius. The normal pressure is given like this, and the question passes on to you. How will you do this? Can you do this? I'll give you time to think. Again, remember, I'm not worried about the calculation. I'm only worried about whether you have understood the question or not. Can you tell me how you have done this? Can you tell me how you have done this? Okay. First of all, you have to calculate what is the heat absorbed, M into L. Did you do the first step correctly? Yes or no?
Yes, sir.
Then you find out how much the volume has changed. Volume has changed by this much amount. For 1 kg it was 91, so for 2 kg it is 182. Then you find the work done.
Yes.
P into delta V. Pressure is given as atmospheric, so you just calculate the delta W. Work done is negative because volume is getting reduced. Yes or no?
Yes, sir.
That's it. So you get delta Q is delta U plus delta W. So delta U will be W minus Q. And this is how it is done. Yes or no?
Yes, sir.
Is as simple as that. This is a good example of a pressure of a process done at constant pressure where it is not specified that this process was done at constant pressure. Do we understand this?
Yes, sir.
We have dealt with one question where the gas was in a fixed container. There also the process was done at constant volume. Here the process was done at constant pressure. This is the type of question that might come. Otherwise, the question would be straightforward. And when the question is straightforward, the answer becomes straightforward. So here is a straightforward question. Tell me what is the answer for this one. What amount of heat must be supplied to 2 into 10 raised to the power minus 2 kg of nitrogen at room temperature to raise the temperature by 45 degrees at constant pressure? Molecular mass is given, R is given. What is the answer for this one? It's a straightforward question. What the answer is? Tougher? Is it a tough one? It's a straightforward one. NCP delta T. Yes or no?
So,
Constant pressure, N, number of moles. Number of moles is not given. Mass is given. You can find out the number of moles and you can get the answer. Yes or no?
yes, sir.
The next one is an isothermal process, a process that takes place at constant temperature. Pressure and volume remains will change. PV is equal to nRT, so P into V is constant. Yes or no? Yes or no? Here, the work done will be given by this formula. Do we know this? nRT log V2 minus V1. Yes or no? Or nRT log V2 by V1. You can, instead of writing log nRT, you can write P1 V1, or you can also write P2 V2. Do you understand this? Can you hear me, beta? Instead of writing it as nRT log V2 by V1, you can write it as P1 V1 or P2 V2, because P1 V1 or P2 V2 is also equal to nRT. Yes or no?
Yes, sir.
Instead of writing it as V2 by V1, you can write it as P1 by P2.
P2.
Yeah, so there are different ways in which you can write this. Now remember some crucial things about this. Here the change in internal energy is zero. Yes or no?
Yes, sir.
Here the change in internal energy is zero. So whatever amount of heat you give is utilized to do work. So change in internal energy is zero. So delta Q is also same as delta W. Remember these small things. Do not forget these small things. Then you have this revolutionary diagram, the PV graph. Do you know how this PV graph looks like? And the what? And the slope of this PV graph is minus P by V. Yes or no?
Yes, sir.
Know this?
I know.
It's a negative slope graph. Yes or no?
Yes, sir.
Okay. Now remember these small things that I'm going to show you, because any of this may come as a multiple choice or a single option type question. So these are different isothermal processes drawn. This is known as an isotherm. Do you know the name of this graph is known as isotherm? Yes or no?
Sir.
They might give you graph like this and they might ask you which is greater, which is less, T1 is more or T1 is more. So here you know that T2 is greater than T1. Yes or no?
Yes, sir.
Boyle's law is obeyed. This is known as an isotherm. Two isotherms are given. The upper wala will be the isotherm at a higher temperature. Niche wala will be at the lower temperature. The curves drawn for same gas at different temperature cannot cut each other. Will you remember this?
Yes, sir.
If two isothermals cut, then T1 and T2 become same, which is not possible. So they cannot cut. Remember these small things. Now remember, there might not be there might be a question where it is not straight away said that it's an isothermal process. They might be giving it in a different way. So an isothermal process, to make the process isothermal, the process should take place extremely slowly. Do we know this?
Yes, sir.
If it takes place extremely slowly, then you will have enough time for heat to go in or heat to come out, heat to go out or heat to come in, so that the temperature of the system remains constant. Do we understand this?
Yes, sir.
An ideal isothermal process must take place in a cylinder whose walls are perfectly conducting. Yes or no?
Yes, sir.
So these are the things that are specified here in these points. The temperature of a substance remains constant during melting. So melting in an isothermal process. Boiling is also an isothermal process because the temperature when it is melting or boiling remains constant. Yes or no?
Yes, sir.
Sometimes you might have sudden changes, but if it takes place in a conductor of infinite conductivity, perfect conductor, then you might also treat the process as isothermal. But ideally, the isothermal process should take place very, very slowly. Do we remember this? Do we know this? Do we understand this?
Yes, sir.
Okay. So remember all these small, small points about isothermal process, and you might be able to solve questions. So here is a question that comes. And let us see if you can do this. Figure shows a process A, B, C, A to B, B to C, C to A. It's a VT graph, remember. Find the net heat given to the system during the process. I'll give you time to do this. A minute. Just tell me.
Yes, sir. From A to B, work done is 0.
A to B work done is 0.
From B to C, work done is NR delta NR T2 minus T1 log V2 by V1.
Wrong. NR T2 minus T1. Which formula are you putting, beta?
Isothermal.
T2 minus T1. You are changing temperature and then you are calling it isothermal.
T1 minus T2.
You are again changing temperature and you are calling it isothermal.
Father.
In isothermal process, temperature cannot change, bacha. Simple mistake will cost you marks, will cost you ranks in the JEE. Think again.
NR T2.
Okay, now correct. NR,
T2 log V2 by V1.
okay. Then what about the process CA?
CA is the isobaric process.
Okay, what is the work done in that process? Yes, you're correct. That's an isobaric process. Yes. Go ahead. Okay, so you have to remember all the points of all the work done. You are correct about this part. You are correct about this part. You're also correct about this part that this is an isobaric process. P into V2 minus V1. I mean, P into V1 minus V2. Yes or no? V1 is the final volume and V2 is the initial volume. Yes or no? P into V1 minus V2, which can be written as, and that is what you have to remember. P into V1 minus V2 can be written as, again, I'm giving you time.
NR delta T1.
P into V1 minus V2 can be written as,
NR T2.
yes, NR T1 minus T2. Do we understand this?
Yes, sir.
Or minus of NR T2 minus T1. And in the entire process, the change in internal energy is 0. You have calculated all the work done. That is the heat given or lost in this process. Do we understand this?
Yes, sir.
So as you can see, it was a simple question. If you could remember the basic concept of how you can write the different work done, you would be able to do this? Yes or no?
Yes, sir.
Before finishing the class, let us finish the next process, the adiabatic one. In the next class, we will move on to the polytropic one. Have you done polytropic process before?
Yes, sir.
Okay, so we'll be starting with polytropic process in the next class. Adiabatic process. Up till now, either volume was constant or pressure was constant or temperature was constant. Now all the three will change, and this process is known as adiabatic. In this adiabatic process, you can write the equation of gas as PV raised to the power gamma is equal to constant. Do we know this?
Yes, sir.
You can also write in terms of V and T. You can also write in terms of P and T, and you must remember all the three.
Delta
Yes
Q.
or no?
Yes, sir. Delta Q is 0.
Yeah. Here, delta Q, no amount of heat is given or lost. That means the process has to take place very, very fast. Yes or no?
Yes, sir.
Okay. And the process must take place in a perfectly insulating vessel. Yes or no?
Yes, sir.
That means so-called, can understand this. This is the reverse of an isothermal process. Yes or no?
Yes, sir.
And you must remember that the work done in this process is nr gamma minus 1 T1 minus T2. It is since the change in it, since there is no heat given, this is negative of delta U. Yes or no?
Yes, sir.
Delta U is NCV delta T.
Delta T.
CV is R upon gamma minus 1. So you do the negative of this and you get this. Yes or no?
Yes, sir.
So remember these small things and you would be able to solve question on adiabatic process, which we will do in the next class. But before going on to the next class, we must discuss the slope of the PV graph for this curve,
Minus gamma
and
P
it
by
is
V.
minus gamma times P by V. Yes or no?
Yes, sir.
So it is steeper than a isothermal. So if it is expansion, isothermal will be on top and adiabatic is the bottom. Yes or no?
Yes, sir.
Gamma for monatomic gas, gamma for diatomic, and gamma for polyatomic. Monatomic gas as the least gamma. Yes or no?
Yes, sir.
So polyatomic gas, monatomic gas, you can easily find out the, or is it ulta? It's even ulta. What is the gamma for a monatomic gas?
Gamma for
Gamma for a monatomic gas?
5 by 3.
Huh?
5 by 3.
5 by 3. Gamma for a monatomic gas. Gamma for diatomic gas?
7 by 5.
And for a polyatomic gas, 9 by 7. Yes or no?
Yes, sir.
Which is more, 5 by 3 or 7 by 5 or 9 by 7? 5 by 3 is more, na? Yes or no?
Yes, sir.
So this graph is given ulta, printing mistake. This must be polyatomic gas and this must be monatomic gas. Do we understand this?
Yes, sir.
Okay. So monatomic gas is the steepest one. Remember this. In the next class, we'll go ahead and solve some questions on adiabatic process, and we'll go and see polytropic process, and we will see the formula for calculating the molar heat capacity for any process, for any polytropic process or any different process. And we might also solve some questions from Irodov as well if the time permits us. Okay, so in the next class we'll try to wind up. Is there anything else you want to do in this particular chapter, or only this processes? That's it.
Yes, sir. Problems we will do. Sir.
Yes, so we'll do more problems. Once we are done with all the process, we will do all the problems together. Okay,
Okay, sir.
chalo then. I'll wind off this class. It's already late. Take care, and I'll see you tomorrow. If you have any doubts, you can definitely ask me. Okay, take care.